song. For your sakes. So I'll start off with a bit of science in a sort of flippant way. These are what we've tried for 30 years on the science. Good intentions, Machiavellian policies, eloquent arguments, legal licenses, lots of accountancy scams, and in that I include net zero. But actually the physics doesn't care about any of that. And I think we have to remind ourselves of that when we talk about the real world or what's practical. Well, it doesn't care about these niceties. It only really cares about the total amount of carbon dioxide and other greenhouse gases that we put in the atmosphere. So that's the sciencey bit over. So where to start? So I'm going to start with the Paris Agreement. Just a bit slow switching, isn't it? Because it's switching via Zoom, so it takes a little while. So start with the Paris Agreement. And what I want to start off with is a few years ago, the focus was really all on 2 degrees centigrade of warming. But now I think there's been a shift much more towards 1.5 degrees centigrade, which is at the same time has happened that our emissions keep going up in the atmosphere. So we've got a tighter target and a smaller budget. And there are ways that that's been fiddled, if you like. So we've moved from 2 degrees centigrade to aim for 1.5. And there are some very good reasons for that. After the Paris Agreement, and it's odd that, again, it's the analysis came after the conclusions, if you like. So the Paris Agreement says, let's have 1.5. And then people said, well, what does that mean? And then we did the analysis afterwards. But so the IPCC were asked to look at this and produce their report in 2018, the SR Special Report 1.5. And broadly in that, it points out that the impacts for 1.5 are pretty destructive across ecosystems, human systems, and so forth. So 1.5 is not a safe threshold. But the impacts of 2 degrees centigrade are considerably worse. And there's quite viable, valid science from people like Hansen and many others who would argue even at 1.5, we pass many really important sort of non-linearities, tipping points. So some scientists suggest that even that is too dangerous a threshold, and others think we will have a little bit more time for that sort of temperature, maybe a little higher. But let's also remind ourselves that our focus isn't on temperature. We're not really interested in temperature. What we're really interested in is the rate of change of impacts. So if the impacts that we're seeing from climate change occurred over 1 million years, so what? If they occur over 500 years, it becomes a bit more important. If they occur over 20 years, it becomes incredibly important. So it's the time frame over which the impact's occurring that's really important. And this language of temperature is just a proxy for the change in impacts. Can our human systems, can ecosystems deal with the change that we're actually seeing and witnessing? And so far, on our human systems in many parts of the world are struggling with the existing climate that we have and the norm that we have today, which will change again next year and the year after. But so, of course, are many ecosystems, and we can see that with some of the ecological destruction, not just related to climate change, but broader sort of human activities. Hopefully some of you have seen these diagrams before. These are quite commonly used, the burning ember diagrams they're called. And it's another one of the sort of managerial tools that the IPCC use. So what we have here is sets of impacts at a global level. And they are taken from really lots and lots of academic work. So there's lots of research behind all of this, and they've tried to simplify it into a set of sort of bars for different types of impacts at a global level. And then sort of use a color to say how bad they are, and not unusually red is bad. But what's interesting is that these have been updated every few years, and what you see is how that what was initially thought to be bad at a certain temperature, that temperature normally gets to be lower. And you look at the latest set and you see the impacts look much worse. And that's one thing we have learned from the science, is the impacts are much worse at lower temperatures than we thought. So we thought they would occur at higher temperatures, now at lower temperatures. And this is one of the strong reasons why we've moved from this sort of, does it work on here? No, it doesn't. From the 2 degrees centigrade framing to 1.5. And let's also be clear again that 1.5 is not safe. And the 1.5 informed COP26. So this idea, this language, rhetorical, political rhetoric really, but keep 1.5 alive. And I think that has also become a much more of a framework for thinking about some of the issues on mitigation as well. So I think there is some genuine concern behind trying to stay at 1.5, because there are good reasons not to go above it, even though the chances of not going above it look incredibly slim. And I think this is something that was said to me quite a lot at the at COP in Glasgow by other colleagues from, well, other people from elsewhere outside the global north. Typically, climate change is not a threat; it's a reality. And the opening day of COP, here's a couple of quotes. There were lots of quotes given on the opening day of the COP, and they're reported by what's called the UN News, United Nations News. They stopped counting the death when the death toll reached 6,000, but there are 1,600 bodies still missing. Massive floods, devastating wildfires, and rising seas, along with countless lives they take and the livelihoods they upend, are realities many nations are already facing. And if you looked at somewhere like Pakistan recently, you look at what happened there. Now, admittedly, that was certainly a very strong climate change signal in that, but also the way the flooding was actually organised in the country was also very much a political decision. So again, these things play on top of each other. But they're sort of, if you like, people will be sometimes to say, well, that's just anecdote. What does the science tell us? Well, it's usually a fairly conservative organisation, the IPCC, the Intergovernmental Panel on Climate Change. So this is taken from Working Group 2. And notice the word have here that I've bolded. So this is at 1.1 degrees centigrade of warming. Increasing weather and climate extremes have exposed millions of people to acute food insecurity, reduced water security, and so forth. And look at the countries that it's mostly impacting so far. Typically, global south countries, typically poorer people, typically people who had nothing to do or very little to do with the predicament we find ourselves in today. Losses of food production and access to food compounded by decreased diet diversity have increased malnutrition. Again, typically for communities outside those that have caused most of the problem. And that in all regions, extreme heat events have resulted in increased mortality and morbidity, so more suffering and more deaths. So the climate change we are deliberately, knowingly producing today when we drive or fly or heat our homes, it is having these impacts today. We are killing people.